Hey everybody, today we are here to talk about Pythagorean triples. That is quite a mouthful. I'm not sure if you have watched our first video on the Pythagorean theorem, or the first two, I can't remember. But if you have, you probably know that Miss Voss loves this topic. And she usually shortens the word Pythagorean to just P. So P theorem, P triples, if you want. All right, so let's dive in. Let's see what we're talking about. Hopefully, you're already familiar with the Pythagorean theorem, and maybe you already know that the word triple means three. So, when we're talking about Pythagorean triples, that is when three lengths make the Pythagorean theorem true and they form a right triangle. So we're going to be giving you three lengths, and your job is going to be to decide, could I make those three lengths into a right triangle? Is it possible, or would it never work no matter how I arrange them? And it would be really cool if we could just give y'all a bunch of sticks of different lengths and you could actually experiment to see if they make right triangles. But that doesn't really work through the computer, and it doesn't really work when the lengths start to get really weird. So instead, what we're going to do is we're going to learn how we can do it with just using the formula. Okay? So this first one says, use the Pythagorean theorem to prove that the side lengths 13 feet, 5 feet, and 12 feet form a right triangle. So anytime we're talking about a right triangle, we're pretty much going to need the Pythagorean theorem. So I like to start every one of these problems in all of these videos with writing the Pythagorean theorem down. Okay? And then we're going to plug in these three lengths for the three variables. I'm going to draw a line like this is one of those regular equations that we solve. The thing is, you can't just plug in any number where you want. You have to pick the largest number, which in this case 13 is the largest, and you have to plug that in for your hypotenuse. All right, and if you remember, the hypotenuse is the letter C. So in place of C, I'm going to put a 13, and I'm going to put that little squared there. And then the two others, the 5 and the 12, actually don't matter. Those are called the legs, and they don't matter which one goes where, so I'm just going to write them in this order. And then I'm going to go through and I'm going to use Desmos to find all of these numbers. So I'm going to type in 5 squared, 12 squared, and 13 squared before I come over here to write them down. So 5 squared was 25. 12 squared is 144. 13 squared is 169. Now, I still can't say for certain that the left side and the right side are equal to each other because on the left side, I've still got these two numbers. So I'm just going to add those two numbers together, like it says, add, and write down my answer. So I got 169 on the left side, and I got 169 on the right side. So that means, yes, these three lengths do form a right triangle. So if I could give you a stick that was 13 feet long, another stick that was 5 feet long, and another stick that was 12 feet long, you could arrange those into a perfect right triangle. Let's try this other one, which is different because it says non-example. So I think this one is not going to work. Let's read. Use the Pythagorean theorem to prove that the side lengths 7 inches, 3 inches, and 8 inches do not form a right triangle. Okay, so this one isn't going to work, but let's figure out what it looks like when they do work, or when they don't work. So I'm going to write down my formula first. A squared plus b squared equals c squared. I know that C is the hypotenuse, and that has to be the longest side. So the longest number here is 8. And you can't rearrange it, and you can't use a different number. So I'm just going to put 8 there. And then the 7 and the 3 don't matter. So I'm just going to write those in whatever order I want. And then I'll use Desmos to help me do my math here again. So 7 squared is 49. 3 squared is just 9. And 8 squared is 64. And remember, I can't tell yet whether these are equal or not. I've got to do something on this side. 49 plus 9 is 58. And on this side, I got 64. So actually, instead of an equal sign, we should have a not equal sign because these do not work. If I gave you a stick that was 7 inches, another one that was 3 inches, and another one that was 8 inches, there is no way on this planet that you could rearrange them to make a right triangle. You could make a triangle, but it wouldn't be a right triangle. And that's all that we care about right now is right triangles. Let's do one more example. This one has words, but it's done pretty much the same way, except we don't know the result this time. We don't know if it's going to work or not. So it says Sabrina has 3 pieces of ribbon measuring 20, 29, and 21 centimeters. Can she form a right triangle with the pieces of ribbon? Well, let's find out. I'm going to start by writing the Pythagorean theorem. And although this is provided on formula sheets, at least in Virginia, I'm assuming most places, it's good to practice writing it so that you have it ingrained in your brain, right? If you write it every time you see the words right triangle, you're going to remember or be more likely to remember that those two things go together. Now, the longest measurement here is the 29. So that means I have to put the 29 in place of the C, but the other two do not matter. And then Desmos is going to help me do some math here and square all those numbers for me. 20 squared was 400. 21 squared is 441. 29 squared is 841. And then I'm still not sure if those two sides are equal until I add the two numbers on the left. So 400 plus 441, oh no, gave me 841, which is equal to the hypotenuse squared. So can she form a right triangle? The answer would be yes. She can form a right triangle. And I think that's it for these notes, guys. Thanks so much. See you next time.